Hi, very good morning to you. It's Gene from Maverickstar Observatory. We're going to be having a look at some recent data that one of our superstars down in Perth, Australia has sent us. Jeff, thank you very much for that. And at the same time, we're going to also just go over a little information about the things that are changing our climate. So we'll have a little review of sunspots, what it is that has changed about the sun. We'll look into a little bit about the effects of both magnetic reversal and the changes in the sun that they have on our planet. And before we get into that, as usual, I just want to say I'm very grateful for the support that we get from you guys. Without that, we couldn't keep our observatory going, and putting the equipment out around the world like we have recently done wouldn't have been possible without those people stepping up to the line. And if you'd like to help support what we do here at the observatory, there's a link down there in the description. So we're looking at the data from Perth, Australia. Only a small data set. What I think there has happened is there might have been a power cut, or they might have forgot to reset the magnetometer after the power cut, and that's why we've received 351 individual data sets of information. But nevertheless, we can see how the data was being recorded at that point in time, and even though there's only 350 segments of information, we get the picture, and we can see that things are pretty normal when we compare it with other data that we've had from Perth, Australia. Not so much of noticeable big changes. There has been a couple of anomalies in the past data, like here on the 12th of the 11th of 2020 to the 16th of the 12th 2020. Towards the end of the chart, you can see a slight anomaly where the magnetic intensity dropped in that region briefly and then picked back up. That would have been over perhaps a few days. Some of the things that can cause that is solar radiation coming off our sun. Sometimes we might just catch a weak glance of a CME, and it can have a little bit of pressure on our magnetosphere, and over that region in Australia we could have been witnessing just a little bit of activity from the sun, just buffeting on our magnetosphere over that region. So big thanks to you, Jeff, for sending the data. Keep it coming in, buddy. And as when we get data from different magnetometers that we've got out there in the field, we relay it onto poleshiftnews.com. So if you want to have a look through the data that we've got on there, you're very welcome. We're having nearly 10,000 people view the data now every week. So I do believe that we are getting the information out, albeit very slowly. At the end of the day, there is really only about 2% of the world's population out of the 8 billion that are even aware of things like the grand solar minimum, and that the Earth is going through a very rare anomaly, that being the magnetic pole reversal. So let's have a look at first of all, a report that was done with regards to sunspots and the solar activity and what is causing the changes therefore in our sun. That was done by a couple of scientists. Let's get into that. So some of you may remember this. This was some research that was conducted by William Livingston and Matthew Penn. It was done before 2015, and what their conclusion was is that after studying over 1,000 sunspots, and in particular the sunspot Umbria from 1990 to 2005, all these measurements showed a consistent trend where the Umbria was becoming warmer by 45 K, and the magnetic field's strengths had decreased by 77 Gauss, and this is why we're getting less sunspots on our sun right now, according to the research that was done by these two gentlemen. What I want to do is to give you an idea of what they're talking about. So we're going to have a look at a diagram where we can see what the sunspot Umbria is, and we can talk about that a little bit more in detail. So in short, sunspots are just solar magnetic activity, and they have obviously been focusing on the umbra, which is the darkest part of the sunspot itself. The outer ring around a sunspot is the lighter penumbra. So what they noticed is that the sunspots were becoming warmer by 45k every year, and as a result this was leading to a decaying strength by 77 gauges per year. And over time we see that sunspot activity has dropped off considerably to the point at where it is now. Now this affects our solar system because when the sun goes through a grand solar minimum like we've witnessed over the last 3 solar cycles, I'll just pull up the chart so we can see that. But what happens is it causes the heliosphere, which is a protective bubble similar to our magnetosphere that protects us from radiation here on the Earth. But this extends, the sun's heliosphere extends to just outside our solar system. So it protects the whole of the planets within our solar system from galactic radiation. And when there is low solar activity, the heliosphere shrinks and we get more galactic radiation inbound. So this is what's been happening, and there has been a few other effects with regards to the the declining of sunspots over the last 3 cycles. You can clearly see we're at the end now of solar cycle 24, and it's looking like a very slow start to solar cycle 25 if it even really does kick off. And there's a bit of debate with that, whether we have actually seen a beginning of a solar cycle 25 emerge. But if it goes on the trend that we can see over the last 3 cycles, it won't be much of a solar cycle at all. And the reason largely to do with that is because of the heating of the umbra by 45k every year, and the declining of magnetic intensity in that region of the sunspot by 77 gauges per year. Now it's really unfortunate that at the same time as us going through here a very rare anomaly, a magnetic reversal, we're also at a point in time where we are being affected by grand solar minimum and low sunspots over the last 3 cycles, which may continue for whoever knows how long. We don't quite know what has caused the change in the effects of the umbra on the sun. I believe that is still a topic of research for solar physicists, but nevertheless, a weakened and low sun output leads to, as we can see on this flowchart, a weakened heliosphere that leads to an increase in cosmic rays in the Earth's upper atmosphere. And at the same time, we're in a magnetic pole reversal. Unfortunately, we find ourselves in this rare point in time where our Earth's magnetic field is also weakening. And when the magnetosphere weakens, not only do we get extra cosmic rays through our solar system because of the low heliosphere inflation, we also get inbound in our upper atmosphere because of the weakened magnetosphere, more cosmic radiation. And you can see on the flowchart how cosmic rays mix with the upper atmospheric particles that allow water vapour to condense on, forming water droplets. Water droplets enter the jet stream, increasing the mass and the velocity of the jet stream, in turn changing the behaviour, i.e. polar jet streams mixing with subtropical jet streams. And this abnormal jet stream changes lead to some of the global climate changes that we're seeing right now. Now, of course, the worrying thing about these 2 things that are coinciding with each other, allowing more cosmic radiation into our upper atmosphere, is quite concerning. And they know, these big main organisations like NASA, the European Space Agency, NOAA, they all know what's going on, and they have been very quiet about this. And the reason why we know that they know what's going on is because they produced this space environment overview. But when they did that, they failed to just conclude what was actually taking place during solar maximum at solar cycle 24. And if we just go to the daily sunspot numbers, and also underneath that the Moscow cosmic ray data, what you'll see is that during solar maximum of solar cycle 24, the atmospheric magnetosphere, I'll get my words out in a minute. The magnetosphere had weakened to a point where it was no longer strong enough to push away the large amounts of cosmic rays during that point in time from the sun, and we can see that clearly on the chart. This is a new anomaly that they should have really come out and made some announcements to the world about, because if we go back to solar cycle 23 and solar cycle 22, we can see that during maximum it pushes it beneath the negative line on that chart, whereas in solar cycle 24 during the maximum it's above the negative line. So what that means is they are fully aware that there is something changed in solar physics, and that change has led to an increase in radiation in our upper atmosphere. So not only do we know that because the sun's low yield of activity has created a situation where we are receiving more cosmic rays inbound to our upper atmosphere, we also know through our research alone here at the observatory that our Earth is definitely going through a magnetic pole reversal, and it has sped up since 1990, covering twice or nearly 3 times the amount of distance in just the last 30 years than what it did the previous 90 years. So we have the facts, the evidence, and we know it is definitely taking place. The worrying thing is that there seems to be a lack of information coming from these organisations that have invested heavily into this. After all, they put the swarm satellites up there in space to monitor the Earth's magnetic field, but revealed very little of their findings about what is actually taking place. So, as you guys know, here at the observatory, we took it upon ourselves to do a little bit of research and investigation ourselves as to what's going on with our Earth's magnetic field, and that's why we've got on the ground at various locations, like in Arizona, here in the UK, Hong Kong and Australia, magnetometers measuring the intensity in those regions, and we will be able to put this information together and get a clearer picture at some point in time. But more than that, through monitoring it every 15 minutes 24/7 365 a year, we're collecting not just the data on this event as it unfolds, but we're also trying to get this data if and when something dramatically starts to happen out to you guys in hopefully a time period where you can make some decisions as to whether you feel that this could be life-changing, and it could be a severe event that could affect everybody's life on the planet, although slowly but surely we know that that is the case, because if it affects the climate, it affects the agricultural production, and we're already seeing this take place. And again, not only is it the worst time to have another anomaly like the grand solar minimum affect the Earth during a magnetic pole reversal, but we also are at a point in time where there's never been so many people on this planet, and there are other anomalies that are on the cards that should have already happened, like for instance, we should be going back into a glacial period now. Is it these two events that coincide with each other, something that sets up that event to start happening? We just don't know. But I think it's common sense that if you get low solar output, you're going to get low solar radiation heating. And one of the things I wanted to do at some point is start measuring. I'm going to have to give it a real bit of thought, start measuring solar output at the surface level. We can measure the intensity But we have to have, obviously, I've got to really get my head around this, because obviously, during every month the sun rises and sets at different angles. So, it might mean that we've got to collect from different locations again, measuring luminosity and output, a year's worth of data before we can reach any conclusions on that. But in short, it affects the climate in changing the behaviour of our jet streams. This is also evident from what we've seen happening. If I show you the jet streams today, and I think I might as well do that. So what we'll see is a completely broken down jet stream system, where there is no distinction between polar jet streams and subtropical jet streams, both over the northern and southern hemispheres. This is what is now changing our climate on a daily basis sometimes, when 1 minute we're receiving polar jet stream and Arctic blast winds, and then the next day we're receiving subtropical weather. And it's this interchange between the two which is causing real big trouble for agricultural production around the northern hemisphere of our planet. And I believe when our governments talk about things like global warming, I think if we reverse it 180 degrees, what we are actually seeing is global cooling as a result. So that glacial period could be coming back in the not too distant future for us. And if that is the case, well, if you've ever seen any artist impressions of what the Earth looks like during a glacial period, you'll see that most of the northern hemisphere is covered in a blanket of ice. And if that is the case, most of the inhabitants that live in the northern hemisphere are going to fail in mass production of food. Simple as that. Guys, I hope you've enjoyed this little overview that I've done for you today. I try always to put it in a layman's terms for you guys. I know that you're not all scientific minded. I know that some of you can deal with a lot of scientific data, but I try and make it understandable for everybody. And I hope that we've given a good presentation of this overview for you. There's a link down there if you want to help support what we do at the observatory. It's all about collecting data, processing that data, getting it up to our website, which is dedicated really just to solar activity and the magnetic pole reversal. So when we get funding, we can do more. It's as simple as that. But I'm really grateful for any help that anyone gives us. And like I said, the link's down there. Only one other thing to say, guys, is try not to get too excited about it or worried about it. We've got no choice. This is nature of not just our sun but also our planet, and we have very little effect on that, and therefore we've got to go through it. So the only other thing to say, guys, is have an amazing day, take care of your loved ones, and as always, bye for now.